My name is Bailey Schwenk, and today I will be talking about my research creating a GIS-based prioritization system for MS4 compliance projects. Urban areas are characterized by their high amount of impervious surface. This high amount of impervious surface increases the amount of runoff in the system. So stormwater systems carry the urban runoff to receiving waters, and the water carried is detrimental to streams and rivers because it is warm, has a high sediment load, and has a high pollutant concentration. Stormwater systems are designed to move water quickly and efficiently. This causes many issues, including high flow, erosion, sediment movement, and a reduction in habitat and water quality. The municipal separate storm sewer systems, or MS4s, are a conveyance or system of conveyances that are owned by a state, city, town, village, or other public entity that discharges to waters of the U.S. is designed or used to collect or convey stormwater. This includes storm drains, pipes, and ditches, etc. It is not in a combined sewer system, and it is not part of a sewage treatment plant or publicly owned treatment works. The NPDES stormwater program regulates some stormwater discharge from MS4s. This is because stormwater is considered a point source pollutant, which means that it needs to be managed. So operators or municipalities are required to obtain NPDES permits and develop stormwater management programs because they are only permitted to discharge a certain amount of stormwater. The stormwater management programs describe the stormwater control practices implemented consistent with permit requirements and minimize the discharge of pollutants from the sewer system. Stormwater best management practices are one of the approaches to reducing stormwater pollution. Ways that this is done include structures or planting vegetation or management in other actions. Some examples of BMPs include retention ponds, swales, or even rain gardens. However, small municipalities have a hard time implementing BMPs for MS4 compliance for several reasons. They need to find areas that are large enough without any existing infrastructure, preferably on publicly owned property or private property where they can get permission. They need to have suitable topographic, soil, and hydrologic qualities, and they need to drain a sufficient area of land so that they are actually capturing the pollutants. The Lycoming College Clean Water Institute is working on creating a college community stormwater partnership with local municipalities in and around Williamsport. The overall goal of this work is to create a GIS-based prioritization tool that will help communities locate potential BMP locations. Phase 1 of this tool is creating a working tool for local municipalities in Williamsport area, and that's what today's presentation is on. Phase 2 is to expand this tool to work throughout the whole Chesapeake Bay region. The general approach is GIS-based, using broadly available spatial data and supplementing that data with input from local partners, and eventually to make it scalable to broader regions. This model shows one idea for the eventual goal of the project, using a large amount of variables and including different types of BMPs, including potentially underground BMPs. However, this is the current scale that we are working at. We have a lot of binary factors that we cut out of the region, and for prioritization score, we are using parcel size and parcel type. We hope to expand in the future. The data used in this research was obtained from multiple sources. And ArcMap was used for all of the GIS work in the project. High resolution land cover data, 1 meter by 1 meter, was obtained from the Chesapeake Bay Conservancy and parsed out to determine the location of roads, parking lots, and other structures. Some of the GIS data was obtained from local partners, including the study area, the existing BMP locations in the area, the combined sewer system, and any additional parsed out areas. The USGS National Hydrography Dataset, or NHD, was used to determine the floodplain area, and the parcel data was obtained from the Lycoming County municipality. There were 3 types of base metrics that were used. One were the binary metrics representing feasibility, where some areas cannot be developed into BMPs. These were all of the areas that would be cut out and would be a 0 on the final prioritization score. This included floodways, existing BMPs, other excluded areas, and all of this had to be within the selected project area by the municipality. Some more of these parsed out areas included the structures, because they cannot build BMPs where there are existing structures. And finally, the roads needed to be parsed out because they could not build BMPs where there are impervious surfaces. The second type of metric used was also binary. However, it represented good or poor quality of land for BMP use. And the example of this is parcel type, which you can see on the map. The public parcels are blue and all of the private land is red, and it is preferable for BMPs that the land be public, because private land is more difficult to work with due to the fact that you need to get permission from the landowners. All of the parcel type data had to be input manually using Excel, and the parcel ownership data. The third type of metric was continuous integer, representing a gradient of condition. The example of this is parcel size. This was done by using Excel and the parcel areas to create a histogram of all the areas of the parcels and divide it into quartiles in order to determine the categories. This means that the smallest 25% of parcels will be the red smallest category here, and the largest 25% of parcels will be the green largest parcels. Here is the final prioritization that was done with the score listed on the side. The total project area was around 41,749 kilometers squared. And of that, 27,967 kilometers squared, or around 67% of it, was parsed out and is shown by a score of 0, which means that BMPs cannot be used in that area. That left only about 23% of available area to build BMPs in. of the final prioritization score in the non-parsed out areas. Here are the percentages of the different scores. As you can see, only about 1.5% of the available area to build BMPs was either a 5 or a 6, meaning a high quality area for building BMPs. This is one area that is an example of a high score. It is the area around the Susquehanna River Walk and is near a storage facility and electrical company. The system shows that this should be an ideal location for BMPs. However, it may not be a very useful location because it is already forested. So the forest will do a good job reducing the runoff to the river already, and creating a BMP there may not do anything or may be detrimental by removing forest. So in this circumstance, the prioritization system did not do a great job. However, here is another example of a high score on the prioritization system. This is township land next to a school district office. This seems to be a good area for BMP work because it is a large open area that is just covered in grass. So it has a large potential to house a BMP and reduce stormwater runoff. It is also near a road and a large parking lot, so there will be a lot of runoff in the area. And it is also bordering a stream, so it may be beneficial in intercepting water prior to entering the stream channel. Here is a location that is already under consideration for a BMP. It is a previously channelized stream that is being considered for channel and riparian wetland restoration. It was found using local knowledge of the area, not the model. However, the model identifies it as an ideal location, which shows that the model is correctly identifying some of the locations that these municipalities are looking for. And even though it is forested, it is suitable due to the specific restoration type that they are looking at doing, which is the channel restoration. The main conclusions of this work are that the overall model works pretty well. However, parsing out large areas severely limits the potential locations of BMPs, but that just illustrates the trouble that these local municipalities are having in finding these locations. In fact, high quality potential sites were only about 1.5 of the total available area in the MS4 urban area. We found that site suitability is related to BMP or restoration type. That was shown in the forested area under consideration, whereas some forested area would be not suitable for BMPs and others is suitable depending on what type of restoration project they are doing. Further work needs to be done to automate the process and limit manual interpretation, such as the parcel type, because inputting public and private land data on a large scale is not feasible. We often had a need to ground truth locations to determine additional context, and working with local partners helped identify ways to improve model development. And finally, There are issues with scalability that we are still working to understand. This includes improvement from partner input, because on a large scale, you would not be able to get all the input from the different partners. And also manual data manipulation limits scalability. Here again is the model showing a lot of the ways that we want to expand the project in the future. We also want to use expert opinions to weight the metrics more accurately, or even add additional metrics, and get help in how to expand the tool to a much broader area. I would like to thank the Arthur Vining Davis Foundation for funding this research, along with the Lycoming College Clean Water Institute for additional funding. I would also like to thank the Pennsylvania Department of Environmental Protection for discussions about their experiences with MS4 permitting. And I would like to thank community partners working with Lycoming College Clean Water Institute on the research, specifically Marcia LeBeau and Wendy Walter from the Williamsport Municipal Water Authority, and Bill Burdett from Loyalsock Township. I will now take questions and comments and would appreciate any suggestions. Thank you.